Now let's look at example 3. Example 3 has 3 different versions, version A, B, and C. The version B and C will be discussed in the next 2 videos. So example 3 is talking about a staffing problem at a restaurant. So for this particular restaurant, it opens from 11 a.m. until 10 p.m. So it serves both lunch and dinner. So if you look at the table, this is time period, 1 hour each. So from 11 to 12, 12 to 1. Column B shows the number of employees needed based on the workload. So for example, from 11 to 12, they need 9 people on duty. From 12 to 1, they need 9 as well. But in the afternoon, because it's the break between lunch and dinner, they don't need a lot of people. So for example, from 2 to 3, from 3 to 4, they only need 3 people on duty. So the column B shows the number of people needed or required based on the workload. And the column C and D shows the working schedule for 2 full-time employees. For this restaurant, they have 2 people work full-time, and the rest are covered by part-time employees. So column C shows the working schedule for the first full-time employee. So this person worked from 11 to 3 p.m. Then take a break, the 1 hour break from 3 to 4. Then we'll work from 4 to 8. So that is the working schedule for the first full-time employee. For a second full-time employee, schedule is from 1 o'clock until 5, take 1 hour break, then work from 6 to 10. So this schedule basically makes sure that there's always at least 1 full-time employee available in any time period. So these 2 columns, C and D, show the working schedule for 2 full-time employees. So this is fixed. It's always like this. Okay, we don't need to make any decisions. It has been this for a long time. So always, this is always scheduled for full-time employee 1. This is a schedule for full-time employee 2. We don't want to change anything. So the rest will be covered by part-time employees. So for this particular problem, we have to determine how are we going to schedule part-time employees to cover all different time periods. So in version A, each part-time employee works 4 hours, okay, non-stop 4 hours. So if you hire somebody, this person will be working 4 hours, not 3 hours, not 2 hours, not 1 hour. It's always 4 hours. So the first thing we need to do is, this is the total number of people we need, combining full-time and part-time. And this is a full-time schedule. First thing I need to do is that I will need to calculate how many part-time employees I need in each hour. So look at the first one. The first one from 11 to 12, I need 9 people. But I have 1 full-time employee available. So B3 minus 1, that shows how many part-time employees I need to hire. Okay, I have 9 available. I have 1 full-time employee available here. That's why I only need 8 part-time employees. So I need to calculate. I do this for each hour and calculate how many part-time employees I need for each hour. For second hour, I need 9. I also have 1 available. That's employee 1. Okay, not 2, only 1. Look at the highlighted area. For next hour, I need 9, but I have both full-time employee available here. Okay, both people will cover this time period, so I'm minus 2. So B5 minus 2, that shows how many people I need, how many part-timers I need. So next hour, I need 3. I have 2, so I only need 1. The next hour, I have 3. I need 3. I have 1 available, so I need 2. The next one, need 3. 2 available. Next, I need 6. 1 available. Next, need 12. 2 available. And need 12. 2 available. Next one, I need a 7, 1 is available. That's employee 2. The last one, I need a 7 minus 1 available. Okay, so let's check the answer. 1. All right, so that's how we calculate the number of part-time employees I need. So this is column E. Now let's look at column H, column G and H. So column G and H shows the shift, part-time shift. So as I said, part-time shift is 4-hour period. Okay, 4-hour shift. If you hire somebody, you don't let this person work for 1 hour only or 2 hours only. This person will be working 4 hours non-stop. So column G lists all the possible part-time shift. So you can hire somebody from 11 to 3, that's 4 hours. You can also hire somebody from working from 12 to 4, 4 hours, 1 to 5, 4 hours, or even 6 to 10, 4 hours. So column G shows all possible 4-hour shift. Column H is something we have to determine. So for each possible shift, how many people want to hire? So do you want to hire 1 people to work from 11 to 3, or do you want to hire 2 people or 3 people? Okay. So 1 people, 2 people, 3 people. So these areas are something we need to make a decision. Okay. So we call decision variables. So right now, let's give some initial solution. So how many people you want to hire to work from 11 to 3? Let's say I need to hire 1 people. Next shift, I need to hire 2 people, 3 people, 4 people, 5, 6, 7, 8. Okay. So what do this number mean? It's just initial solution to start with. It doesn't really matter. If you don't like it, you can just put all 0 here. It will not affect your solution. So this is just the initial solution. So look at this. All these part-time shifts, they overlap with each other. For example, 11 to 3 overlaps with 12 to 4, overlap for 3 hours. 12 to 4 overlaps with 1 to 5, overlaps for 3 hours as well. Okay. So this is a solution. It's not the optimal solution. It's not even feasible solution. Okay. But based on this solution, what we want to do is we want to fill column F. So let's say if this is in fact your optimal solution, and what is the number of people who will be working for each hour? So look at column A and G, pay attention. Column A and G, G is a shift, the 3-hour shift. So it's always 3 hours, 11 to 3, 4-hour shift. It's a 4-hour shift, so 11 to 3, 4-hour shift. So each row represents 1 shift, 4 hours. But if you look at column A is period. It's not time shift. It's an hour period, 1 hour period from 11 to 12, 12 to 1. No overlap. So now let's see if this is something you want to do. What will be the number of people who will be working in different time period? So look at first time period from 11 to 12. From 11 to 12, who will be working from 11 to 12? Look at these people. Okay. These are all the people we have. Okay, look at these people. So look at these people. Who will be working from 11 to 12? So if you look at shift, you can see the ones who's working from 11 to 3 will be working from 11 to 12. Okay. This one person will cover the time period from 11 to 12 because this person will work for 4 hours from 11 to 3. So this person will be working from 11 to 12. So the total number of people who will be working from 11 to 12 equal to this. As I said, we use formula. We don't type a number. Okay, we use formula. So equal to H3. Anybody else will be working from 11 to 12? If you look at the other shifts, if you check other shifts, anybody else will be working from 11 to 12. You can see no. Okay, this is the only person who will be working from 11 to 12. Let's look at second time period. Second time period from 12 to 1. Okay, so look at these possible shifts. Who will be working from 11 to 1, or from 12 to 1? So who will be working from 12 to 1? first shift, the first person will be working from 11 to 3. So does this shift 11 to 3 cover the period from 12 to 1? The answer is yes. Okay, whoever working from 11 to 3 will be cover the period from 12 to 1. So this person will be available from 12 to 1. Anybody else will be working from 12 to 1? Will be this person. This person is working from 12 to 4. The ones who's working from 12 to 4 will be covering the period from 12 to 1. Okay, so it's H3 plus H4. Next, who will be working from 1 to 2? Okay, 1 to 2, who will be working from 1 to 2? Let's look at all these possible shifts. So 1 to 2, this person, 11 to 3, covers 1 to 2. This person as well, the ones who's working from 12 to 4 will be covering the period from 1 to 2. And plus this person, the ones who's working from 1 to 5 will be working from 1 to 2. So H3 plus H4 plus H5. Next, who will be working from 2 to 3? So will be first person plus this, and plus this. You can check. Okay, so these three group of people will be working from 2 to 3. So who will be working from 3 to 4? So 3 to 4, you can check who will be working from 3 to 4. So this person plus this, and plus this, and plus this. So these four group people will be working from 3 to 4. So you can do this for each of the following time period. So this will be H5 plus H6, H7 plus H8. The next one will be H6, 7, 8, 9. Next one will be 7, 8, 9, 10. Next one is a little bit different. Okay, who will be working from 7 to 8? So who will be working from 7 to 8? Look at all these possible shifts. Who will be working from 7 to 8? Okay, the ones who are working from 3 to 7, this shift does not cover 7 to 8. The first one that start to cover 7 to 8 in this one. Okay, so will be this one. 4 to 8 will cover 7 to 8, plus this, plus this. So these three shifts will cover the period from 7 to 8. What about next one, from 8 to 9? So who will be covering the period from 8 to 9? If you check it, you can see this shift plus this shift. What about the last one, from 9 to 10? Only this shift. Okay, only this shift. So we're converting the number of shifts to the number of people on duty for each hour period. So you have to check which shift covers which period. Okay, it's a little bit tedious. Make sure you do it carefully. So now we're done with filling the table. We have to solve it. So before we solve it, we have to think about three elements for a typical decision problem. So one is that objective, and then decision variable, then constraint. So what is the objective here? The reason we try to optimize staffing problem is we don't want to overstaff. Okay, we want to have enough people on duty, but we don't want to hire too many people. We do not want to overstaff the restaurant, because if you hire more people, you're going to pay for more. So this is about really controlling the operating cost. So make sure you only hire enough to cover each period, but don't hire too many people. So really here, the question is really about minimizing the total number of people we need to hire. Okay, we want to meet the requirement. The requirement is specified by this number. So this is how many people we need for each hour. How many part-time employees we need to hire for each hour. We need to meet this requirement, however, but not too much above this requirement. So our objective is to minimize the total payment, okay, total pay. So what I want to do is, I forgot, I need to fill 2 more cells before I use solver. So let's look at here. Let's say this is your solution, okay? Let's say this is your solution. What I want to know is, if this is your solution, how many people you will be end up hiring on each day, okay? How many people you will be hiring on each day. So I hire 1 people to cover the first shift, 2 people to have 7 shift, 8 people for the last shift. So how many people in total? The total number of people I need to hire is the sum of all this. So this number shows how many people I need to hire for the entire day. So it will be 36 based on my current solution, 36 people. The last one shows how much I need to pay them. Okay, I need to pay for 36 people. 36 people. Each person will work 4 hours. 4 hours. That's 4-hour shift. The hourly rate is 7.5. This is given by the problem. So everybody gets paid for $7.50 per hour. So each person works 4 hours. So that is total pay. Currently, if this is your solution, you are going to need to pay $1,080 per day. That's your cost. Okay. So now let's think about 3 elements about the decision problem. So what is your objective? My objective is to make sure the total pay is minimized. Okay. I don't want to pay too much. I'm the restaurant manager. I want to make sure I have enough people, but not overstaffing. Okay. So that's why I need to make sure this number is smallest. So minimize the total pay. That's my objective. Second element we need to be clear is what is your decision variable. So clearly these green numbers are decision variables. I need to determine how many people I need to hire for each possible shift decision variables. The last one is about constraint. Okay, so what is your constraint? If you don't have a constraint, we will be simply hiring 0 people for each shift. That will minimize the total pay, will be 0, right? If we don't hire anybody, we don't have to pay at all. But that's not the case. Okay, that's not the case. So we have a constraint. Our constraint is this one. Okay, this is a constraint. This one says we need to have this many part-time employees on duty in different time period. So this is a constraint we have to meet. We have to have this many people on duty, this many part-time employees on duty for different time period. And column F shows the number of people hired or number of people available, hired available for each hour. Yeah, based on solution, I calculate how many people are available for different hour. This is how many required. This is how many scheduled. Okay, how many people you actually scheduled to cover different hour. So I need to make sure these numbers will be at least this many. In other words, column F has to be more than or equal to column E. Okay, so these numbers have to be at least the same as column E. That means requirement. That's called constraint. Okay, so you have to have enough people scheduled, okay, to meet this requirement. So that is a constraint. Now let's go to solver. Objective. That is a H12. It's your objective. This is the pay. We are the restaurant manager, so we want to minimize it. I don't want to overstaff and pay too much. Minimize this number by changing variable cells. So what is our decision variable? Decision variable, I choose all the green numbers. The number of people to hire for different possible shifts. Constraint, as I said, there's one constraint. The number of people scheduled for each hour has to be greater than or equal to. Okay, has to be greater than or equal to the number of people required. So F3 to F13 has to be greater than or equal to E3 to E13. So that is our constraint. The last one is that before we solve it, we want to make sure choose the right solving method. So here again, we use simplex LP and click solve. Okay, it's pretty fast. So we already solve it. The total pay we need is $600 based on solution. $600. So your labor cost per day is $600. If you was a manager, restaurant manager, you know your labor cost is $600 per day. Only for part-time employees. This one does not include the full-time employees. That's separate. That's a fixed payment. Okay. Now let's look at what's the solution. So you are going to hire 8 people to work from 11 to 3. You don't hire any people work from 12 to 4. Nobody work from 1 to 5. I have 2 people working from 3 to 7, 3 people working from 4 to 8, and 7 people from 6 to 10. So based on this, you can hire different people. The total number of people we need to hire is 20 people. Hire 20 people, we end up paying $600 per day. So let's look at requirement. From 11 to 12, I have 8 people. That means requirement. 12 to 1, 8 people available. I need 8. That means requirement. For the next hour, 1 to 2, I need 7. I have 8 available. That's good. Okay, you have 1 extra. So in some period, it's exactly the same. In some period, it's a little bit more. Okay, because there's no way you can do perfect match. Because everybody high, you have to hire this person to work 4 hours. That's why these 2 columns will not be exactly the same. So in certain periods, it will be overstaffed. For example, the last 2 hours, you'll end up having 1 extra person. Okay? There's no way you can do better because each person you hire, this person will work 4 hours. So that is a solution.